In this video, I'd like to talk about rational functions and their points of discontinuity. Now, before we look at a specific example, let's talk about this generally. We're going to be looking at the zeros to our function, the vertical asymptotes of our function, and the removable discontinuities, which graphically resemble holes in the function. So let's look at a picture of some random function that I've drawn, and we can just call this f of x or whatever we want to call it. Now, a point that passes through the x-axis, like this point right here, let me change colors. So this point right here, this is what we call a zero, or essentially it's an x-intercept of the function. Often these are called the roots of the function. So a zero is when the y value, or the function value, is equal to 0. So in these rational functions, that's when the numerator will be equal to 0. Now right here you can notice this is a dashed vertical line, and this is what we call a vertical asymptote. And asymptotes, or vertical asymptotes, are just values of x, our independent variable, that leads to the denominator being equal to 0. So in this case, we would say, since we're at an x value of 2, that x cannot equal 2, since in this made-up function, if we were to plug 2 into the function, we would end up with a denominator of 0, and you cannot divide by 0. So vertical asymptotes are where you have division by 0. Now, holes are a very similar situation, but it's a little bit more complicated. Or more formally, we call these removable discontinuities. And these discontinuities are also not part of the domain, just like vertical asymptotes. In this case, this is an x value of 4, we would say x cannot be 4. But we don't end up with an asymptote. This is kind of a unique situation. And let's look at a specific example here. Let's say f of x is equal to x minus 1. Let me just scroll over just a bit. And the numerator can be multiplied by x minus 4, and the denominator can also be x minus 4. So you can see if you plug 4 into our denominator here, that you end up with 0 here. But if you plug in 4 to the numerator, you also get 0 up top. So this is what we call an indeterminate case, where you have 0 divided by 0. And in those cases, basically what you can notice is that this factor up top and this factor down below, these would cancel each other out, and your function, if I scroll over just a bit more, this would be equal to just x minus 1, and we'd say when x is not equal to 4. When x is equal to 4, the function doesn't exist. But otherwise, it would just be this linear function, x minus 1. So these removable discontinuities, this is the case where you're able to cancel out a factor in the top and in the bottom for whatever that particular x value is that's not in the domain. So these are the three cases. A vertical asymptote would be a case where maybe this was x minus 5 and you couldn't cancel this out. In that case, 5, or the x value 5, is not in the domain, and we end up with this dashed vertical line here where the function cannot cross over that. Holes, at least, you can see that the function essentially passes through it almost, and the function would be valid at all points up to that specific x value. But you do kind of get this smoother looking curve where, again, it just isn't valid at that one point. Whereas in an asymptote, the function will shoot up to either positive infinity or will come down to negative infinity, and the function will essentially hug along this asymptote. So they're a little bit different. Now, with that in mind, let's try and look at some specific example problems.